Good morning, friends. Let us discuss another problem on the development of lateral surface, the truncated pyramid. Those who are watching first time my channel, please subscribe my channel, like the button, press like the button, and share my videos to your friends for latest updates in computer aided engineering graphics. Let us begin with the new problem. The problem is a square pyramid of side of base 45 mm. It's a square pyramid. Base edge is 45 mm. Altitude means height, that is 70 mm. Is resting with its base on HP. Base resting on HP with the two sides of base parallel to VP. That's a condition is given. The pyramid is cut by a section plane which is perpendicular to VP and inclined at 40 degree to the HP. The cutting plane bisect the axis of the pyramid, obtain the development of lateral surfaces of truncated pyramid. Let's start this problem. It's a square pyramid. Usually we are aware about a square pyramid. Generally the top view is a square and front view is a triangle. Let's construct a top view and front view of a square pyramid. So I'll go to line. Let's draw an XY line, an horizontal line. This is on horizontal XY line. Okay. Now I'll construct the top view. Top view is a square. It's a square of 45 by 45. I'll go to rectangle, choose thick line or thin lines, choose thin lines, and these two are 45 by. So I'll construct the top view is a square of 45 by 45. 45, this is 45. Let's keep angle is 0. So I'll construct a square of 45 by 45 like this. Okay, now let's find the center for this. Draw the diagonal lines, we'll get the center. If you draw the diagonal lines, you will get the center for this. Now draw the projection lines. I draw vertical projection line till XY line. I draw vertical projection line from center to XY line. I draw projection line till this point. Now the axis is given 70 mm. Let's draw an axis line. So from here, height should be 70 mm and it should be a 90-degree line. Now let's complete the front view. I told front view is a triangle. Let's complete the front view. This is the front view of this triangle. Now let's go for naming. I'll go to text times Nero. Let's keep this is corner A. Let's keep this is keep font size is 3.50, and let's keep this is corner A, this is corner B, this is corner C, this is corner D, and this is O1. Okay, now this is O dash, this is O1 dash, this is B dash of A dash, and this is C dash of D dash. Okay, I got the front view and top view of pyramid, square pyramid. Okay, now next step is I'll introduce a cutting plane. Is given condition: the pyramid is cut by a section plane or cutting plane which is perpendicular to VP and inclined at 40 degree to HP, 40 degree inclination to HP, and also this cutting plane passing exactly, it will bisect the axis of the pyramid. Since let's check the length, so this should be 45. Okay, and this height is it is given 70 mm. Now let's draw an horizontal line. Like this, and this distance should be 70 by 2, it will bisect. This distance should be 75 by 2. Let's make 75 by 2, so that is 37.5 mm. Now let us introduce a cutting plane. This is the cutting plane, third or fourth option. Let us introduce a cutting plane, so it should be inclined. So let's zoom this area and try to introduce the cutting plane. I'll go here, pick the intersection point, simply draw an horizontal line, inclined line like this, and measure its inclination. That should be it should be 40 degree to HP, not axis. This and this should be 40 degree. And extend this line. Let's extend this. I'll extend this till this point. Okay, so this inclination is 40 degree. This inclination is 40 degree. Now let us introduce, let's go for naming. I'll trim this, let us fit the sheet, and I'll zoom only this part. Let's zoom this part. Okay, now in the next step, we need to find the true slant edge length. So how do you find the true slant edge length? I'll draw an horizontal line from O of O1. Now I'll go to arc by center. Let's keep this is the center. And this is the radius. Let's draw an arc till this XY line. Then next I'll draw projection line from here to till XY line. Then I'll join this and the apex point. Now this is the true length. This is true slant edge length. Let's maintain some different color for this. This is the true slant edge length. Look at a pink color line. That is the true slant edge length. Okay, so now let us go for naming. I'll go to text, and this will intersect. Say this is 1 dash. Okay, this point is 2 dash of 3 dash, and this is 4 dash. This is this is 4 dash. This is 4 dash. Okay, now next step is, let's draw projection line, vertical downward projection from 1 dash to A, then B till B, then from here two dash of 3 dash to here. Let's draw projection lines, vertical projection lines. Now I'll go to line. Let's make thicker line. Join this. These are all visible lines. Okay, these are all visible lines or visible edges in the cutting plane. After introducing the cutting plane, these edges are visible. These edges are visible. Okay. Next step is, let's zoom this section and this is the cutting plane. Below the edges which are present below the cutting plane, those edges are visible. Let's make visible lines. Okay, this is visible, and this is visible, and this is the true slant edge. Okay, now just draw or projection lines, the horizontal reference line from 1 dash of 4 dash to true slant edge length, from 2 dash of 3 dash to true slant edge length. Now you need to take this measurement. Okay, now this become 1 dash of 4 dash, 1 dash of 4 dash, and this become 2 dash of 3 dash. Okay, so this is the front view and top view of a square pyramid after introducing a sectional plane. Now let's move on to the development of the same solid. So now in the next step, I will let's check this length, the true slant edge length. So true slant edge length, I am getting a 76.89. Now I'll go to arc base center, take this as center, and this is 76.89 is the radius. Let's construct an arc like this. I'm doing development. Okay, now let us join this end point and this center somewhere here. Okay, now the base edge is 45 mm, so I'll go to arc base center, keep this is the center, and radius is 45. Let's cut this line. Now they keep this is the center, radius is 45, and cut this line, cut this arc. Similarly go here, select this, let's zoom this and try to complete. We go to arc base center, take this is center, radius is 45, and cut this arc. Similarly take this is center, radius is 45, and cut this line. So now you can see, now I'll join these points. I go to line, let's join this intersection point and this apex, this and this, join this intersection point and this apex point, join this and this apex point. Okay, so I've done the extra line, I don't want this extra. Next step is this is O, this is let's keep this is the O. Okay, and now this is capital A, this point is B, this point is C, this point is D, and this point is A. Okay, now I'll go to line, let's use thicker line, join A, connect A and B, B and C, C and D, D and A. Let's join like this. Okay, now I need to mark 1 dash, 2 dash, 3 dash, 4 dash on this development. Let us mark this. So now in this case, so we need to measure what is 1 dash, 2 dash, what is the distance between this and this. Let's measure this distance. Okay, I'll spread this line. I'm spreading this with respect to this point. I go to split. I split this line with respect to I am splitting this line with respect to this end point. Okay. Let's measure this distance. I want this distance, and also I want this distance from here to here. I need this distance. Sorry, I want this distance. I need these two distances. Let's measure this distance also. I need these distances. Okay, so now the next step from O, this is the O, from here to here, the total distance is 28.12 to mark 2 and 3. Okay, 2 and 3 belongs to B and C. Go to arc base center, keep this is the center, and radius is 26.12 press center, and 2 and 3 belongs to C and D. CD belongs to 2 and 3. This is C and D. So let's cut this line, and let's cut with the same center, and this is 26.12. This is 26.12 press center, and cut this. Okay, C and D, 2 3 belongs to C and D. Okay, and 1 and 4 belongs to A and B. So 1 4 at a distance of this distance. You can add these two. 28. Sorry, this is 28. 28.12. Okay, and this is 28.12. So this is 28, right? 28.12. Okay, next this is 28.12 plus 20.77. Good arc by center. Radius, this is the radius. Radius is 28.12 plus 20.77 is the radius. So I'm getting 48.89. Let's cut this. Again similarly this 48.98. Cut this, again cut this, then cut this. Last point 48.98. Press center and cut this line. Okay, now the next step is very simple. Let's join these points. I'll go to line, choose thicker line. Let's join this, join this. So go to line, this and this. Let's join these two. Join this and this. Join this. So I'll join this and this. Join this and this. Join this and this. join this and this, and join this and this. Okay, I don't want this on. Let's trim it. Now this is 1, this is 4, this is 2, this is 3, this is 1. So this is the development of lateral surface development of truncated pyramid. Thank you so much for watching my video.